How much protein do you really need? It's not only bodybuilders and strength athletes that need to be concerned about their protein intake. Proteins are essential building blocks for the human body, and getting enough protein is key to good health. Not getting enough protein can lead to weak bones, hairs, and nails, feeling constantly hungry, brain fog, bad mood, muscle weakness, and a poor immune function. Protein is essential as a building block for bone and muscle, as well as for enzymes, certain hormones, and other molecules. But how much protein is optimal? Now, you've probably seen a lot of conflicting numbers thrown around by health organisations, doctors, and social media influencers. I remember being told when I was first starting out in the gym that I needed to consume around 2 grams per kilogram of body weight of protein every day, or about 1 gram per pound, in order to gain muscle. But the World Health Organization, along with many other health bodies, have set the recommended daily allowance for adults at around 0.8 grams of protein per kilogram of body weight. However, is this level actually optimal, or just the bare minimum requirements to prevent a deficiency? Now, we know that protein is one of the main building blocks for muscle, and is therefore key to building and maintaining muscle and for muscle recovery. And so one way to gauge what the optimal protein intake might be is to look at studies that have examined the effects of different protein intakes on muscle mass. According to the International Society of Sports Nutrition, or ISSN, the recommended daily allowance of 0.8 grams per kilogram per day is not appropriate for most people who do any significant amount of exercise, and is only really a bare minimum maintenance dose for sedentary individuals without much muscle mass to prevent deficiency. But what about those who are more physically active or have more muscle? One 2007 study looked at 21 experienced strength and power athletes in a 12-week resistance training program. Participants were randomly assigned to 2 groups. One group was given a protein supplement and the other group was given a carbohydrate placebo. The high protein group was consuming 2 grams per kilogram per day of protein, and the placebo group consumed 1.2 grams per kilogram per day. The study found that those in the high protein group experienced significant increases in lower body strength, increasing their maximum squat by 24 kilograms for the high protein group and only 9 kilograms for the placebo. This was also backed up by a 2012 meta-analysis that looked at 22 randomized controlled trials that were examining the effect of protein supplementation combined with resistance training. The studies included were at least 6 weeks in duration and were conducted on both trained and untrained adults with a range of ages. The authors found that protein supplementation produced a large increase in muscle mass and strength compared to placebo, with younger adults supplementing protein gaining roughly 1 kilogram more muscle after 12 weeks compared to those not supplementing, and this effect was even larger in the resistance trained subjects compared to those who just started resistance training, with the resistance trained subjects that were supplementing protein showing a greater than 4-fold increase in muscle gain compared to placebo. And this was with participants already consuming more than 1.2 grams per kilogram per day of protein, and supplementing on average 50 grams on top of this. And so the baseline protein consumption of the participants was already significantly higher than that of the WHO guidelines to begin with before supplementing. For endurance training, on the other hand, there seems to be little benefit to performance from higher protein intakes over 1.5 grams per kilogram per day. However, higher protein intakes have been shown to improve muscle recovery and decrease muscle soreness. Therefore, for those who are physically active or have more muscle mass to maintain, a minimum of 1.4 to 2 grams per kilogram per day is recommended. Those who do more endurance training or have less muscle to maintain would be on the lower end of that, and those who do more resistance training or have more muscle to maintain would be on the higher end. Multiple review articles have also shown that for fat loss, higher intakes than this could be beneficial, by helping to prevent muscle loss on calorie-restricted diets. Protein is also more satiating than carbohydrates and fat, and contributes less to fat gain. And so, for those on calorie-restricted diets, a higher intake of at least 1.8 to 2.7 grams per kilogram per day has been suggested to aid in fat loss and muscle preservation. Studies have also shown that as we age, our bodies actually require more protein as they're unable to use protein as efficiently as when we were younger. And so the optimal levels for older individuals are thought to be higher than those for younger ones. What about protein sources? Not all protein sources are created equally. The quality of protein sources matters as well as the amount of protein. There are 20 amino acids that are the building blocks of proteins. 9 of these amino acids are essential, which means that they cannot be created by the human body and can only be obtained from food. different sources of protein can have different amino acid compositions, and some can be more easily digested and absorbed than others. And the human body requires a certain amount of each amino acid each day. In order to compare the protein quality of different foods, scientists have come up with a couple of different ways to rate foods. One of these is called the Digestible Indispensable Amino Acid Score, or DIA score. The DIA score rates the foods on amino acid composition, as well as how easily they are digested and absorbed. What the DIA score tells us is that animal sources of protein are superior to plant sources of protein in their amino acid composition and how easily digested and absorbed they are. And so those getting their protein from plant sources will likely need to consume more protein than those getting it from animal sources, which may not be as easy as plant sources have less protein to begin with. One study compared supplementation of soy and milk protein. They took 56 young men, assigned them identical resistance training programs, then randomly assigned them between taking a soy or a milk protein supplement. The supplements were matched in macronutrients, each providing 35 grams of protein within 1 hour after exercise. And they found that the milk protein promoted significantly more muscle growth than the soy protein did, despite both supplements being perfectly matched in their amounts of macronutrients. What about protein per meal? Now, you may have heard it suggested previously that the body can only use about 20 to 35 grams of protein per meal. And this, at least to me, doesn't seem very intuitive, as it's not like our ancestors would be consuming protein bars and protein shakes every hour. And indeed, recent evidence suggests that this is not correct. And actually, the body is able to use at least 70 grams of protein per meal, and probably even higher. The suggestion of 20 to 35 grams originally came from studies looking at maximizing muscle protein synthesis. But the anabolic response of a muscle, that is, the ability to build muscle, depends on both protein synthesis and protein breakdown. Larger intakes of protein in a meal lead to greater reductions in protein breakdown, leading to more muscle growth. And so 20 to 35 grams might maximize your muscle protein synthesis, but larger intakes in a meal lead to greater reductions in protein breakdown, which then leads to more muscle growth overall. It's also thought that some of the extra protein might be stored in tissues such as the gut, and then later released to provide protein to other tissues like the muscles. This also explains how higher protein diets of 2 grams per kilogram per day of protein or more were able to maximize muscle gains, even though they were consuming a lot more than 20 grams of protein per meal. What about protein timing? Now, many of you may have heard about the idea of an anabolic window after working out. The idea that there is a period of time shortly after working out, which might be 30 minutes or an hour after working out, that is the most effective time to ingest protein for maximizing muscle growth. However, according to one 2018 article, this is also false, and in fact, based on the current evidence, there is little to no effect of protein timing on muscle gain. The muscles are thought to be sensitized to protein intake for at least 24 hours after exercise, and so the window of opportunity for protein post-exercise is thought to be relatively large. And so whether you consume protein 3 minutes after a workout or 3 hours after a workout likely doesn't make too much difference. Although if training fasted, there's likely more urgency to consume protein post-workout. What about other protein supplements like creatine or branched-chain amino acids? Branched-chain amino acids, which are leucine, isoleucine, and valine, are important building blocks for muscles and a common supplement. But many high-protein foods, particularly animal foods, contain a lot of branched-chain amino acids with 100 grams of beefsteak containing 6 grams, which is more than a typical 5-gram supplement serving. And so if you're getting enough high-quality protein, then supplementing with BCAAs is unlikely to be of any benefit. Creatine is also a common supplement that helps with muscle gain, strength, and injury prevention. Typically, creatine supplements are 3 to 5 grams per day. Creatine is found mostly in muscle meat and fish, but in order to get 5 grams per day from beef, would require eating at least 1 kilogram of beef. And so creatine may actually be worth supplementing for those who aren't consuming a lot of protein from meat and fish. Lastly, I want to address if a high-protein diet is safe. One study took 30 healthy resistance-trained participants and assigned them between a control group and a very high-protein group. Those in the control group consumed their normal diet of roughly 1.8 grams per kilogram per day of protein, and those in the high-protein group consumed 4.4 grams per kilogram per day, which is over 300 grams per day. The study reported no harmful effects of this high-protein intake, and also saw that despite consuming a lot more calories, the high protein group saw no significant changes in body composition and no increases in body fat. So increasing your calories through consuming more protein doesn't seem to lead to fat gain. The safety has also been confirmed by other studies, including one which looked at a high protein intake of 3.3 grams per day per kilogram over a year, and observed no negative effects on blood lipids or liver and kidney function. And so high protein diets seem to be perfectly safe for those with healthy kidneys, and indeed there is tribes like the Inuit that consume relatively high protein diets with no adverse effects. And so to wrap up, it looks like a minimum of 1.4 to 2 grams of protein is the optimal. Higher protein intakes are required for those doing more resistance training and with more muscle, and those who are more active, and lower protein intakes for those doing more endurance training or who are less active. As we age, our protein requirements also increase, and those who are on calorie-restricted diets will also want to consume more protein to help preserve muscle mass while losing body fat. Protein quality is also important, with lower quality proteins requiring more protein to be consumed to get sufficient amounts of each essential amino acid. The protein intake per meal doesn't seem to matter very much, and the timing of the protein intake also doesn't seem to matter very much. But what is important is getting enough protein per day. For more great informative content, then check out the rest of my videos, and if you want to support the channel, you can do so via PayPal or Buy Me a Coffee, which are linked in the description below.